For nearly a century, a ghost has been haunting the world of physics. It's a puzzle so strange, so completely counterintuitive, that Albert Einstein himself called it spooky action at a distance and flat out refused to believe it was real. He went to his grave certain that science would eventually find a simple, hidden explanation he was sure had to exist. And it's stranger, simpler, and more profound than even Einstein could have ever imagined. But it never did. Generation after generation of the world's brightest minds have wrestled with this ghost, and not one could pin it down. Until now, because a new kind of intelligence, an artificial mind, just took a look at this decades-old problem and found an answer. This isn't just a small step. This is the kind of breakthrough that could fundamentally change the future of computing, communication, and our very grip on reality itself. We are standing on the edge of a cliff, looking out at a world where the biggest secrets of the universe might not be solved by a human, but by the very minds we've created. The ghost that haunted Einstein might just be the first of many to be laid to rest by the spooky mystery of entanglement. To really get the scale of this discovery, we have to go back in time and get inside Albert Einstein's head. By the 1930s, the man was a titan. His theories of relativity had completely redrawn our map of space, time, and gravity. He had set down what he thought was the ultimate law of the cosmos. Nothing, absolutely nothing, can travel faster than the speed of light. It was the universe's final speed limit, and buried deep inside it was an idea that seemed to break Einstein's most fundamental rule. It was called quantum entanglement. Their properties, like their spin or polarization, would become intertwined. They would act like a single system, no matter how far apart you pulled them. Now, here's the spooky part. The very instant you measure a property of one particle, you would instantly know the property of its twin. And you wouldn't just know it. In a way, you would determine it. The act of looking at one particle seemed to instantaneously change the other, whether it was across your lab bench or across the entire galaxy. But this new theory was bubbling up. A bizarre and fuzzy world called quantum mechanics. There were no secret instructions. The spookiness was real. Reality, at its very core, is not. The theory went like this. You could take two particles, say 2 photons of light, and link them together in a deep, mysterious way. Creating and controlling entangled particles became a core challenge of modern physics. The methods scientists came up with were incredibly complex and inefficient. A common technique, entanglement swapping, is a perfect example. Scientists would have to create 2 separate pairs of entangled particles, then perform a ridiculously delicate measurement, called a Bell state measurement, on one particle from each pair. This measurement sacrifices those 2 particles. But in doing so, it magically causes the 2 remaining particles, the ones that never even met, to suddenly become entangled with each other. For him, it was a blatant violation of the cosmic speed limit. It looked like information was traveling faster than light. He famously scoffed at it, calling it spookhaft fernworking, or spooky action at a distance. It works, but it's slow, expensive, and a nightmare to scale up. For decades, everyone just accepted this was the price of admission into the quantum world. They assumed this was how it had to be done. They were wrong, and it took an AI to prove it. He was convinced it was a mirage. There had to be some hidden information, hidden variables that the particles carried with them from the start, like a secret instruction manual. This instantaneous link is what horrified Einstein. I keep one box here and mail the other to the far side of the universe. The second I open my box and see a left-handed glove, I know with 100% certainty that the other box holds a right-handed glove. There's nothing spooky there. The information was decided from the moment I packed the boxes. Einstein was sure that's all quantum particles were doing. Think of it like this. I have a pair of gloves. I put each one in a separate, identical box. But physicist after physicist, through decades of painstaking experiments, proved Einstein wrong. And so the question changed. If this spooky action is real, how do we use it? This process is clumsy and a massive bottleneck in research. It's like trying to build a skyscraper with handcrafted tools. Rewrote the rules. And it's not a person in a lab coat, but a specialized AI tool called Pythois was built by an international research team, including scientists at the Max Planck Institute for the Science of Light, to help design quantum experiments. This is where our hero enters the story. They didn't ask it to discover new physics. An elegant solution hiding within a well-known principle of quantum mechanics. Indistinguishability. The underlying physics was already known, but the AI found a much more efficient way to apply it. They just asked it to rediscover the established ways of creating entanglement, and it worked perfectly. A CERN physicist who wasn't involved in the work said the authors were able to train a neural network, and the network actually learned the physics behind it. The AI didn't just guess. It understood the physics so deeply it saw a more direct path to the solution that humans, stuck in their old ways, had missed. It looked at the ghost that haunted Einstein and, instead of fighting it, found a beautifully simple way to summon it on demand. They could create conditions where the simple act of detecting photons in certain spots guaranteed that other photons, which had never directly interacted, emerged in a perfectly entangled state. Like that entanglement swapping method. That's the core idea the AI latched onto. If you set up an experiment where photons from different sources have their paths cross, and you do it in such a way that it is fundamentally impossible to know which source a photon came from, you can generate entanglement out of thin air. When the photon's origins become truly indistinguishable, the universe essentially starts treating them as a single, unified system. The human researchers were skeptical. They figured it was a glitch in the code, or that the AI had misunderstood the problem. For decades, the assumption was that complex steps like Bell state measurements were essential. The AI solution just seemed too simple, too clean. It flew in the face of years of established science, but the AI was persistent. It kept spitting out the same, simpler answer. So, the scientists decided to actually build it and see. The AI, that whole point was just to see if the AI could learn the existing science and come up with the known solutions that humans had already found. The researchers gave Python what seemed like a simple task, sifting through mountains of data about quantum experiments. And it learned. It successfully figured out the methods humans were already using. But then, it did something no one expected. It kept suggesting a different solution. A solution that was way simpler. So Python got to work. At first, what Python had done was find a brilliant shortcut. Here the researchers built the experiment exactly to the AI specifications. This wasn't just a clever engineering trick. What we're seeing here is a huge shift in how science itself gets done. For centuries, big breakthroughs came from human flashes of insight, from geniuses like Newton and Einstein. But now, we've got a new partner in the quest for knowledge. If you think this partnership between human and artificial minds is one of the most incredible stories of our time, make sure you subscribe and hit that notification bell. You will not want to miss what comes next, because the shockwaves from this discovery are just starting to spread. The wow factor, a quantum future. So, what does having a simpler way to create quantum entanglement actually mean? It means the future just got here a whole lot faster. This isn't just some abstract idea for a physics journal. It's a key that could unlock a technological revolution. So many of those sci-fi technologies you hear about are stuck behind one major bottleneck. The difficulty of generating entanglement, not just hard to hack, but impossible to hack according to the laws of physics. That's the whole promise of quantum communication. It uses entangled particles to secure data. If anyone tries to eavesdrop on the signal, the very act of looking at it breaks the entanglement, which instantly reveals the eavesdropper's presence. Pythias's discovery doesn't just chip away at that bottleneck, it smashes it. First up, the quantum internet. Imagine a global communication network that is truly unhacked. The problem has always been scaling it. This is one of the first times an AI has gone beyond just spotting patterns and has actually uncovered a novel and more efficient, experimental design that top human scientists had overlooked for decades. It shows that AI can be more than a calculator. It can be a genuine creative partner. Algorithms like Python can explore millions of possibilities without the baggage of human bias or preconceived ideas. It's a whole new way to do research, where human creativity asks the questions, and AI explores the vast, untamed wilderness of possible answers. A global network needs quantum repeaters to extend entanglement over long distances. The old, clunky methods made this a monumental challenge. But with this new, simpler, AI-powered method, building those networks becomes dramatically more realistic. They are a completely new type of machine that can solve problems that are literally impossible for even the biggest supercomputers we can imagine. They could help us discover new medicines by simulating molecules perfectly, invent revolutionary new materials, and design financial models of unimaginable complexity. A world of truly secure global communication is now a giant leap closer. But building a useful, large-scale quantum computer means managing entanglement between thousands, or even millions, of qubits. The power of these machines is rooted in their ability to use quantum effects like entanglement, but maybe the biggest deal is what this means for science itself. The problem's still unsolved, okay? It's really important to be precise about what this discovery is and what it isn't. The title of this video is a bold claim. AI just solved the physics problem that stumped Einstein. Now, if we re-talking about the practical problem of generating and controlling the very spooky action that Einstein could understand, then yes, an AI has given us a stunningly simple solution that eluded scientists for years. But did it solve the deep, philosophical mystery that truly stumped him? He dreamed of one single, beautiful theory that could unite the forces of nature, specifically gravity and electromagnetism, into a single mathematical framework. He was hunting for the master equation, the theory of everything, the fundamental why behind this. No, that's a completely different challenge. And this breakthrough doesn't mean AI has solved Einstein's other great, unfinished quest, a unified field theory. And a big reason he failed was that he was trying to build his theory while ignoring the other two fundamental forces we now know about: the strong and weak nuclear forces. More importantly, his deep distrust of quantum mechanics meant he was trying to build a unified theory on classical, deterministic ground, completely sidestepping the weird but essential rules of the quantum world. An AI has shown us a new, better path forward, but the highest peak Einstein's dream of a final theory is still hidden in the clouds, waiting for the next breakthrough. For the last 30 years of his life, Einstein was obsessed with a different ghost. He never found it. Today's AI has not solved this. Even a system as clever as Python's is great at optimizing solutions within the known laws of physics. It isn't yet capable of making the kind of wild, conceptual leap needed to invent a whole new theory of reality. That grand challenge uniting general relativity and quantum mechanics into a theory of quantum gravity is still arguably the biggest unsolved problem in all of physics. So while we celebrate this incredible step forward in our practical ability to use the quantum world, we also have to stay humble. Think about the journey we've just been on. It started with a puzzle that baffled the greatest scientific mind of the 20th century, a spooky action that seemed to break the rules of space and time as he understood them. For decades, physicists wrestled with this spookiness using complicated, brute force methods, thinking it was the only way. An AI, free from human bias, analyzed the possibilities and found a secret that was hiding in plain sight. It found a solution that wasn't more complex, but dramatically simpler. And then, a new kind of mind took a look. But it's done something even bigger. It's changed the scientific process itself. We are now in an age where human curiosity can be supercharged by the power of AI, where our intuition can be guided by the logic of algorithms. But that leaves us with a new, thrilling, and maybe slightly unsettling question. Einstein's incredible imagination gave us a new universe. Now, AI is giving us a new way to explore it. This discovery is already changing the game for quantum technology, speeding us toward a future of unhackable networks and world-changing computers. The ghost that haunted Einstein has, in a practical sense, been tamed. What other secrets of the universe are just sitting there waiting for the right mind, human or artificial, to find them?